Hello everyone, welcome back to Machine Organization and Programming. In this lecture, we're going to be taking a look at the compilation process. We're going to be breaking it down into all of the individual steps that the C compiler goes through, taking source code all the way to machine code. Quick note that a lot of the clips from this particular video were actually taken from the summer 2020 lecture, and in particular, you're going to notice that the Canvas homepage looks different. All of the links that you need, though, to get to either PuTTY or to get to the account activation for your CSL machine. They're in different places on the Canvas page, but all of those links are still there and they have the same name. Today we're going to be looking a little bit more at this build process. So this is going to be more of an interactive experience. I want you guys to go grab a computer and follow along with me. Make sure you can get through all of these steps and do this with me. So I'm going to go ahead and I'm going to be writing this sum.c file, our first C program, with all of the stuff you need to make this run. So the lines up here, the lines down there. We're going to be going through this process. We'll be stopping at each one of these steps and examining the output that we get for all of these sum.i, sum.s, sum.o files, and finally running the executable. All right, so to get there, we need a couple things. I'm going to jump over here to our course webpage. To actually get to the computer science laboratory machines, you'll need a CS account. So I'm going to click this one, activate your CS account. This is the first step. If you've taken classes at the University of Wisconsin before, you'll probably have already done this. If you just transferred to the University of Wisconsin, go here, create your new CS graduate student user account, or activate your instructional account. Where is it? Activate account right there, up at the top. Do that. These do expire. That was part of the trouble I ran into when I was preparing for this lecture, and this is the reason it's delayed, is that my credentials had expired and I needed to go back through the lab to get them to reactivate me. So I've been on a semester by semester contract, and at the end of the last semester I'm switching from this part-time instructor, short-term employee, to the full-time faculty associate. So there was a change there. So I needed to get this fixed. Second really important thing, if it doesn't work, the forgot password link is right there, also on this page. All right, so once you've got your instructional account all set up, we'll be connecting to one of the computers remotely. So remote access to the CSL computers is right here. I'm going to click that. What we'll be doing is connecting to the Linux machines, and all of our code is going to be run on these machines. You guys are welcome to write it anywhere, but it must run on the Linux computers. So we're going to be connecting to those via SSH, which stands for Secure Shell. I'm going to click that right there. Macintosh and Linux computers are very easy. Your terminal program comes with SSH already built into it. You can basically just pull up whatever the equivalent to, so I'm using command prompt here as my proxy. Command prompt will not work. PowerShell will not work. But if you go to your Mac, your Finder, and then pull up terminal, this should work. All you need to do is type SSH to call up the Secure Shell login program, and then type the name of the computer you want attached to. So in this case, bestlinux.cs.wisc.edu. I know that's really tiny. I'll make it bigger on the next screen, but that's all there is to it. You should be able to click that from the terminal, and it will launch the Secure Shell program. Works for Linux and for Mac OS computers. Windows is a little different. We don't have a good SSH client built into our terminal program, the command or PowerShell. So instead what we'll be doing is using PuTTY as a SSH client. So if you're on a Windows machine, you'll need to install this. Let me just go ahead and grab this link right here, and I'm going to stash it there so I remember to put it in the description. So that way you can just, as you're following along, there'll be a link you can just click. All right, I'm going to open up this page and talk a little bit about PuTTY. PuTTY is an SSH client. For Windows machines, you've got two choices. They're right here on this page. In fact, let me grab this link, put that in my description. So when the video goes up, that'll be in the description. I'm using the 64-bit version right here. Use this only if you have a 64-bit processor and a 64-bit operating system. I'm using Windows 10, the 64-bit version. I've got a really nice new modern computer, so this is what I want. If you've got an older machine or you're using a different operating system, then you want this one. both of those conditions need to be met before the 64-bit version is a good choice. So either one of these, this will just launch the installer. I've already done this, so I can just go down to the Windows Start button. I can type PuTTY, bring that up, and then I don't have to show you guys all the video games on the desktop. All right, now to log in, I'm just going to go here. Oh, one more thing. There are lots of different choices for Linux machines. So here's the Linux. Where's the... There it is, instructional Linux computers. So here there are other choices. We've got Rockhopper 1 through 9, Royal 1 through 30, that's the big lab, Snares 1 through 10, and Emperor 1 through 7. You can choose any one of these machines and use that as the name. Otherwise, you can actually just go ahead and type in best-linux, and then it's always going to be cs.wisc.edu. So bestlinux.cs.wisc.edu. And for even quicker access, I can put my username in. It's going to ask me that as I log in, or I can just add it right here. So in this case, Doescher @ and then whatever machine. Best Linux will choose one of these machines, Rockhopper, Royal, Snares, or Emperor, whichever one has the lowest load on it right now, and sign me into that automatically. It just gives me the best choice. Okay, so I'm just going to go ahead and click Open, and this should open up the SSH connection. It looks like a terminal program. Let's see, I'm going to make this full screen. All right, timeout. I'm going to figure out how to make this bigger. 1 second. Okay, I'm back. Figured out how to make it big enough for you guys to see. All right, so I've just finished connecting. It's telling me I'm using my username Doescher. This will be your CS username. My Wisc username is mdoescher, so it's a little different. And it's also different from my Canvas username. So you want the CS login username. And that'll be a separate password from your Wisc login. It's the one that you get when you activated your CS account. It's telling me up here that I'm connected to royal-30.cs.wisc.edu. That's the name of the computer in the lab that I'm currently using, Royal 30. And I need to just give my password. So looks like that worked. Okay, so give me a whole bunch of instructions about using the lab. It's using Ubuntu. There's some updates I need to do, maybe later. And then down here, this is the command prompt. This whole first line from that bracket all the way over to the $sign is the command prompt. It tells me that I'm logged in as Doescher to this particular machine. If I want to take a look around, I've got a couple of ways that I'm going to use to navigate. PWD is shorthand for print working directory. I can see that I'm in, so this first slash here will be the root directory. That has a bunch of folders in it. I'm in the U folder /D/O Doescher. So this is my home directory. This is where all my files are. If I use ls for list, it can show you all the work I did when I was in graduate school and some of the stuff for when I was teaching. Okay, so yeah, pause the video. Make sure you can get here so far. There'll be a video about navigating the terminal and a video about using Vim coming shortly. But go ahead, catch up. Make sure you guys have been able to at least log in. If you're using Mac or Linux, just go to your terminal, type ssh space, then best Linux CS Wisc edu. If you're using a Windows machine, go ahead and install PuTTY and log in using PuTTY, and then come right back. Okay, so now that you're logged in, you're caught up with me. What I'm going to do is I'm going to navigate to the directory where I'm going to be working. So I'm going to go to my private directory right here where I do all my work. So cd private. So that means that unless you're watching the video, you can't just go and steal the stuff from me. And then you can see all the stuff, all the projects I worked on when I was teaching or taking other classes. So lots of weird stuff, old stuff. All right. So anyway, I'm going to go to my teaching directory. And we'll take a look at what's here. So this directory only contains CS354. So CD 354. And we haven't done any work yet. So when I list the files and directories in this directory, there's nothing here. So I'm going to make a new directory, mkdir, for lecture 1. We'll call it lecture 1. and we'll jump in there. This should also be empty. And this is now where I'm going to create that sum.c file that we'll be exploring today. So to do that, I've got a couple of really good choices. I'm going to use a text editor that's built right into the system. Emacs, EMACS is a really good choice. A lot of people are happy with that. I'm a Vim user, so I'm going to go with Vim, and that's what I'll be doing a video on. If you're familiar with either of those, your choice. Go ahead and use whatever you want as a text editor. There's some great options out there. You guys are welcome to use any IDE you want. You're welcome to write your code on any machine you want, but it must run on the laboratory Linux machines. So I highly recommend that you take this opportunity to learn a little bit about Vim if you're not familiar with it, or Emacs if you choose that option instead. And I think using these just regular text editors, they're designed to write code as fast as possible. I'm not that good at it. There are people out there that are just brilliant. They're designed to work with without having to take your fingers off the keyboard to use the mouse to move things around, which makes it a lot faster to be able to do a lot of operations once you get good at all of the commands. All right, so anyway, I'm going to use Vim to create a new file. It's just a text editor. I'm going to call it sum.c. It's .c is the extension for C code. All right, when I bring this up, so Vim is a mode-based text editor. It's got several different modes available to me. We're only going to be using two today. The first one, it starts out in command mode. And the first thing I want to do is switch to insert mode. So I'm going to just type I to get to insert mode. Switch back to, I to get to insert mode. And now it's going to let me type some text. I can do anything I want as far as like editing the text. Okay, so now I'm going to go ahead and write some C code. Then we'll save it. We'll go back to the terminal and we'll compile it. So first up, as I'm writing C code, I need to begin with the main function. This is going to be the entry point when I call when I run the program. This is where it's going to start. Now main is a function and it takes parameters, so I'm going to need the parentheses there, and the contents of the function are going to be inside of curly braces. Finally, it is a function, and the main function returns an integer, so I need to put the return type before the name of the function, and then it needs to return a value at the very end of the function. So return 0 is the signal that everything is all good, we were successful. It is the not an error sort of code. Okay, now for the rest of what we have going on here, I have an integer a. All these lines end in semicolons. There was b, c, and then finally a was equal to 1, b equals 2, and c equals a plus b. All right, I just got done teaching in class in Python where semicolons are not required. I'm double checking, make sure I got them all. Things are looking good. We need to declare the type of all variables. Python doesn't need that. I'm double checking just to make sure. I'm going to make a ton of mistakes like that for about the first week until I get good at this again. All right, so this looks good. I'm going to go ahead and save this. To do that, I need to get back to command mode, push escape, and then the command to save things is W, :W. You can see it in the lower left there. So that's right. So now it's written. It tells me I've written 109 characters, 19 lines, and then to get back to the terminal, Control Q, Q is the command to quit, and we're back at the terminal. Okay, I'm just going to clear this screen, and now I'm going to call the compiler. So GCC is the name of the compiler we'll be using. G stands for GNU, C compiler, C, the middle C is C, and the last C is short for compiler. So this takes a bunch of options. The compiler is kind of complicated, and the first thing I need to do is I'm going to tell it that my output file, I want it to be called sum. The next option is the name of the input file, which is sum.c. And then two more. I want to compile for 32-bit computers, so -M32. That's for a 32-bit machine. Your other choice is 64-bit machines. If that doesn't make sense, just know that it's using fewer bits, so as we look at the code that's produced, it's a little bit easier to understand and see what's going on. And we'll be talking more about that quite shortly. And the last one I want to do is WALL with a capital W. This is the option to treat all warnings as errors. So any little thing that I mess up will produce an error for the compiler. It'll stop the compilation and tell me about it so I can get it fixed. There's a lot of things that are illegal in C programming that I tend to do that are not what I really intended. You know, I write something, make a mistake. It happens to be legal C code, and I'll point out those things as we go through the course. So I'm just always going to use that option. Okay. In fact, I got a warning right here from the start. Warning C is set but not used. So on line 6, I've got int C. So let's go ahead and take a look at what I'm doing with that line. And so to do that, I'm going to go back to pull up my code. So I can see here I've declared C. I've assigned something to C, but I never actually do anything with it. Okay, so when I run this code, nothing's going to happen. So let's go ahead and we'll print it out, and then we're actually doing something with it. So I switches me back to insert mode. The command to print something, there's actually many choices, but printf is the one I'm going to be using right now. It's a function, so it gets parentheses. I'll need a semicolon at the end. And printf takes a format string and a list of arguments. So let me, the sum is, so it'll print some text, and then what I want to do is insert that variable C into this string. So what gets inserted is, there in purple, it's the %d. The percent sign is the Q that printf is going to take. The function printf will take this, and it's going to put in whatever variable. So it'll go through them in order. This is the first %. It grabs the first variable from the rest of this list. So in that case, this is the C, and it's going to insert it right here. The D just tells this that C is going to be, we want it represented as a decimal number. The other choice would be like a floating point number, which is an F, or a string, which would be %s. There's some other choices and some other options, like for controlling how many, the precision of floating point numbers, for example. We'll do that later. Right now, this is all we need. Just need to print out that number. All right, and I remembered my semicolon. This looks good. I'm going to push escape to get back to command mode. We're going to write this with colon W, and then colon Q to quit. All right, and then back to this same compiler. Now, GCC, output file is sum, input file is sum.c, compile for 32-bit architecture, all warnings. Okay, now I've got a different mistake. Oh, I know what I did. Anyway, let's talk about this. These warnings are important. So warning, implicit declaration of function printf. So I'm using printf, but I never actually declared it. It's an implicit declaration. So it can't find printf. So in fact, there's a note here telling me that printf is provided in standard IO library. So I need to go back and add this line so that this will work, so that it knows where to find the function printf. So I'm going to go ahead and do that. Whoops, oops. Okay, what am I doing? Top level, insert mode, pound, include. So the pound sign is the key for the preprocessor. It knows that this is a preprocessor directive, and the preprocessor is going to do something. In this case, include is going to tell it to go grab all the contents of this stdio.h. I can type stdio.h to go grab all the contents of that library and just include them right here. All right, that does not require a semicolon. It's a preprocessor directive. All right, colon WQ, save and exit. All right, excellent. Looks like I've got it all working. There was no error messages. When things work, the compiler just doesn't do anything. So in fact, now if I were to list all the contents of this directory, I should find my sum.c file. I've got that right there. I also have a green sum with a star on it. The star means that it's executable. So I should be able to write, I need to say ./sum. The / tells that I want to run the sum file that's in this directory. If I've got another sum program somewhere on my path that's valid sum, it doesn't know, the computer doesn't know which one I want. So the / just tells it that I want the one that's right here in this directory. Okay, cool. It works. So I'm looking right here. It says the sum is 3. And then I've got the command prompt right there on the same line. I never put a new line in. Let me go back and add that. I'm a perfectionist. So I'm going to go ahead and edit this one more time. So right here after the %d says print out the number 3, my answer. I'm going to go ahead, I'm going to go back to insert mode, and I'm going to add the \n right there for a new line. So just like a lot of other languages, Java, C++, MATLAB, Python, all of these use escape characters for special characters, an escape sequence. So the backslash here tells this format string that this is a special character, and I want to add a new line here. So N is for new line, T is for tab, backslash, we'll let it print the backslash character, things like that. Okay, so that should do what I want now. WQ for write and quit, and compile, no errors, and run. There we go. The sum is 3, and we've got my new line there now. All right, so the command we just gave to the compiler did all of these steps. It went from sum.c through all 4 steps and ended up with sum. What we're going to do now is we're going to add some extra options to that GCC line to tell the compiler to stop after each of these steps. So the first thing we'll be doing is looking at what the preprocessor does. It's going to go through and create sum.i, the preproc source file. So let's take a look at that and see what it looks like. That's there we go. Okay, so to do that, I'm going to go back to my compiler line. My output file, I want to change this to sum.i. I'm going to stop at this stage. I'm still going to begin with sum.c, and I need to add one more option, the -e, capital E. These are case sensitive. And this is going to tell it to stop compiling right after it does that preprocessor step. So run this, no errors. Let me list all the files in the directory. I can see that I now have a sum.i. And if you're curious about this, more help, I can go to the help pages, the manual pages, man GCC. Yep. So this is not exactly easy to process, to read, but I can see that I've got a number of standard options up here. -C is the one that will compile the whole thing. -S will get me to the assembly code. Okay, so I've scrolled all the way down to the -E option just to show you guys what this is. It's actually like 1,000 lines into the help file. So it says stop after preprocessing stage. Do not run the compiler proper. That's the second stage. The output is in the form of a preprocessed source file, which is sent to standard output. And we've directed that to be sum.i. So let me get out of here. I'm going to push return to end the search, and then Q. There we go. Okay, lots of Q's to exit the manual page. All right, and I've got my sum.i right there. So let's go ahead and take a look at this. This should be a text file, so I should be able to just open it up in Vim. Vim sum.i. And the first thing I notice is that there's a lot of stuff here. Let me just scroll down. A lot of stuff, and more stuff, and more stuff. In fact, it's grab some page down. What do we got here? Looks like 753 lines. Wasn't my program like 19 lines long? So here's what's going on. That very first line, the include standard io.h, basically just tells the preprocessor to take the entire contents of the standard io.h file and copy and paste them in right here. And that was for the sole purpose of being able to access the printf function. So somewhere in all of this stuff, in front of somewhere above line 754, where my program actually begins, what we'll find is that there's a declaration for that printf. So to search in Vim, it's the / key, printf, and now that should take me to, there's the first option. Yep, I remember. So / gives me the search, then I can type in printf, and then I can use lowercase n to move between all the different instances of printf. Capital N will move back up. The one I want is right here on line 427. So this is the declaration of the printf function. It's going to return an integer. It takes a character string, a bunch of options for the different variables that will be inserted into that, and it tells me that it's going to be defined somewhere else. So in order for C to actually use a function, it needs to know what to expect. I need to know that I can assign this to a variable, and it needs to be of type int, and what options it takes. And we'll do more to look into this much later. Okay, So I just wanted to highlight that so we can see that it's copied and pasted in all of this extra stuff. Okay, so next thing I'm going to do is go back. We'll exit. I didn't need to save it because I didn't make any changes. And we'll go ahead and we'll take a look at that next step. One sec while I switch back to PowerPoint. Okay guys, so we just finished the first start of the build process and looked at sum.i and created a pre-processed source file where it just copied and pasted in the header file that included the printf statement. The next thing we're going to do is run the compiler proper. This is what's going to give us the assembly code. And the command that we need to do and stop after the compiler proper step is -s. So let's see here. Here's my compiler line. So instead of -e, I'm going to add -s. I'm going to be creating a sum.s file, and as input, I'm going to be giving it the sum.i file. I can actually start with sum.c if I want, but then it'll run the preprocessor again, and that's not necessary. I've already got it. So let's check this out. I ran that line, and now I should have a sum.s. Yep, there it is right there when I list the files. And we should be able to read this with Vim also. It's a text file. Vim sum.s. Okay, what we're looking at here is assembly code. Actually, pretty soon in this semester, we'll be writing some of this ourselves, and this will, believe it or not, make a lot of sense. So we just take a look at this. So let me see if I can spot some of the... Yep, okay, right here I see the call to printf in line 38. In line 31, this is the sum line. This is saying take the contents of this register and add them to the contents of this register and write the result in this register. And then remove that, the whatever's in that register, back into, this would be the variable location for C. Up here above this, we've loaded registers ECX and EDX, those two registers, with some data. That's probably A and B. Yeah, I think those are the things I wanted to highlight. So anyway, we're going to be writing code that looks just like this in just a few more lectures. Okay, so I jumped back over to PowerPoint, and the next thing we're going to do through this build process, we ran the preprocessor, we ran the compiler proper, that gave us the assembly file, is we're going to let the assembler now run and turn that assembly code into binary code and generate the relocatable object file, the sum.o. So I'm going to go do that right now. Let me see. Hop back over here. So this is still in Vim. I want to quit this. And the command to do that is capital C. I still want, I'm creating an relocatable object file, and I can give it the assembly code version. Okay, so when I do that, let me see, make sure that worked. Yep, I now have a relocatable object file. It says this is executable. The linker hasn't run, so if I run that, it's still missing the, what's the word? Printf definition. That is not actually brought in until the linker runs. So let's take a look at this. If I open sum.o in a text editor, it's going to try and interpret this text, all the data there, which is binary, it's ones and zeros, but it's going to try and decode it as though it were text. So what we're looking at here is pretty much garbage. So we're not actually going to be able to do this. We'll talk a little bit about how characters are represented as binary in the next, pretty soon in the class, actually quite early. Let me get out of here. There are ways that we can use to look at binary files. And the first one I want to look at is with a program called obj dump. And this is standing for we're going to dump out the contents of an object file. So, and we want it to disassemble the object file. We don't want to look at just the binary. And the file I want is sum.o. All right, let's take a look at what this gives us. All right. So, let's see, where does it begin? Yep. So here's the command that I just typed to get this, and here's all this stuff. So first, a bunch of extra information. Down here, these are essentially the line numbers that we're looking at. These are the binary code, but represented as hexadecimal, topic of tomorrow's lecture. And then here's the decoded assembly version of these commands. Okay, the other way that we can use to look at binary files is with a program called XXD. This is going to dump out hexadecimal contents. Actually stands for hexadecimal dump. And I'm just going to give this sum.o. And what we see here is very similar to what we were looking at before. I've got essentially line numbers here on the left-hand column up to the colon. And then in the center, let me scroll up to the top where it begins. Yep, here we go. And line number 0, we've got these hexadecimal values for the binary. And then over here on the right side with this .elf beginning there, this is if we could interpret these binary numbers as characters, what would they be? So if we look down, a lot of it's just gibberish. I did have some text in there. The sum is, so we should be able to spot. I don't see it yet. Still don't see it. There it is. The sum is %d. This was that format string that I put in. So those characters are actually represented, and we can translate them into characters again. All right. Well, let's see. This does take one other option. I can add a -b. So instead of printing out all of the contents of the file as actual hexadecimal, I can print it out as binary also. So we can actually look at the ones and zeros going into this. So now we have fewer columns, but these are the exact ones and zeros of the binary file. And kind of looks like the matrix going on right here as we look at the more interesting stuff. Okay, so the very last step here is the linker. When we ran the full GCC compilation process, like the very first thing we did, it did all the steps all in together, and we didn't break it down into any parts. But the last thing the linker is going to do is it's going to go and grab the definition of printf. That's located in printf.o somewhere out with the files associated with the compiler. The linker knows where to go get it. We don't have to tell it where it's found. It's going to take care of all of that just on its own. And it's going to put all of those together along with the code that's needed to actually turn this into an executable all into one file and generate this sum without an extension, the sum executable. Okay guys, that's going to do it for this video. I hope you were able to follow along and go through these steps and actually get a chance to play with this, look at the code yourself as it appears on your screen. All right, have a great night everybody.